k nearest neighbor. Okay, so what do you mean by k nearest neighbor, right? Definitely you can say that there is some k value that I need to calculate, right? Looking at the name by itself, you can definitely say, hey, what is this k? Definitely it is trying to catch the attention of any end user. And nearest neighbor, friends, can someone talk about that? What do you mean by nearest neighbor? If you wanted to explain this in a couple of words, what do you mean by nearest neighbor?
The one that's close, the data set or the element that's very close.
Okay, so the moment we talk about nearest neighbor, it is all about similarities, isn't it? Likeliness and not likely, right? So it is always trying to talk about similarity. It means if you wanted to explain the entire functionality of k nearest neighbor, it can be simply explained using a maxim. Friends, what do you mean by maxim? M-A-X-I-M. Have you ever heard about an English word called as maxim? What does a maxim do? Right? A simple phrase which is trying to communicate the story very clearly. Okay? So the entire functionality of k-nearest neighbor can be explained by using a simple word which is called as birds of a feather flock together. Can someone explain now? Birds of a feather flock together. What does it mean?
How
Similar.
the
Go ahead, Ajay.
all data get grouped, right? Automatic. So where they fall, how they get categorized and fall under a particular category. What is the closest category it will fall under?
Okay, but I was just expecting you to talk about this particular maxim.
Okay. So all
They're
the
like,
birds.
it's like,
Birds
it's
are
like words like
Guys, one at a time, please. Okay, no one is talking.
Yeah,
Ajay, go ahead.
so, birds with similar flock together. It's like similar entities. They all be together, like all the birds of the same
Simple, right?
category.
Similar entities will always exhibit same properties, so the reason they are staying always together, isn't it, friends? The moment you look at your sky, right, you always see in the mornings where the bunch of species of a particular bird species is always trying to flock together, right? They stay together. Why? Because they share a lot of common in between, so the reason they are going to stay together. So similarly, when you're trying to talk about the data too, don't you think it would try to behave in a very similar manner? The moment you see a set of records having some common objective differently, their similarity among themselves would be very similar, isn't it? Agree or not, friends? Agree?
Yes, Darsh.
Yeah.
So this is what the complete understanding or the functionality of k-nearest neighbor can be compared to. So in other words, right? In other words, what does it think? Things are alike, are likely to have the properties or characteristics or similarities that are alike. Simple. So this is the fundamental property which is helping you to solve one of those fundamental and very good machine learning model which is called as k nearest neighbor. Okay, and if you wanted to see how does this work, right? For the sake of simplicity, friends, for the sake of simplicity in all the machine learning cases, I'm going to consider only one variable or two variables so that we will get to know the understanding of this particular machine learning algorithm. But do not ever think that in real time it is going to work with one variable or two variables, because in the prior batches I keep on getting questions, sir, can I use k nearest neighbor only with what, two variables only? No. For the sake of implementation, for the sake of explanation, we cannot work in 10 dimensions or 12 dimensions, right? Understanding a two-dimensional figure would always be easy. So there is I'm using some of those basic examples for you to understand and observe the content. But never assume saying that since Dhanush told me only x-axis and y-axis, so it will work only for two dimensions. Okay, never be under false assumption. Are we clear on this, friends? From now we'll be using two-dimensional figures because it is easy for us to understand and explain. Because you cannot visualize 5D and 10-dimensional and try to relate this. Are we clear about this, friends?
Yes.
Very good. Now, the entire functionality, as I said, right, how it is working. So the moment you observe this, so there are two axes, right? X-axis and y-axis are two variables and have some set of 100 data points. The moment you try to understand the coordinates of each one of those data point, right? Because on x-axis there is like from 0 to 10, and on the y-axis, say as an example, from 0 to 100 or some different values. I'm not bothered, but I'm going to see these data points. Say as an example, I have 100 data points as part of my data set. Okay, and I have put in all my 100 data points onto this two-dimensional picture. So the moment I see, after I put this as part of the coordinate values, because each data point has some characteristics, say x1 and x2, and x1 has 1 and x2 has some value, I'm immediately trying to put a dot as part of the dimensions or as part of the coordinates of that particular record. Now the moment I try to complete all the projection of all the data points using their coordinate values, you see a group of bunch of records, I can round it off and I call it as class 1, W1, W2, W3. It means all the data points that are present in each one of those uh, borders, right? They are having similar properties. Agree on this, friends?
Yes, Anush. Yes, Anush.
Yes, right? So the moment I have a new data point, now you see there are 100 data points. I was able to project all those 100 data points as part of their x1 and x2 values, because there are two values that are being given in the data set. And the moment I see a new variable, or the moment I see a new instance or a new record, say I got 101 record. Now how can I classify it? The simple what k nearest neighbor is trying to say, like go to the k nearest neighbors. What is k here? I'm going to explain, but for now say that I wanted to compare a new data point with respect to the 5 existing data points and try to take a majority voting. Simple. You got this point, friends? Xn, what you see in the middle, is a new data point that I need to classify it. How can I classify it? I'm going to compare the characteristics of my new data point with respect to my existing data points. Okay, and how many data points? 5. For now we say that let's 5, and I'm going to say how can you optimally find the k value. But for now, say I'm going to compare the new data point with respect to the 5 existing data points present in my data set. And looking at this, so the new data point is similar to 4 orange data points which are called as W1, and one neighbor is from the class 3. Now how can you classify it? Whether should I classify it as W1 orange, W2 blue, or W3 green squares?
W1 orange.
Why?
Because majority are the similarities are major with that group.
Simple. So this is how your entire k-nearest neighbor works. It means whatever the data that you have, you try to call it as a training data. The moment you wanted to predict, the moment you wanted to classify a unlabeled example, when I say xn, this is unlabeled. It means I wanted to find its corresponding label, whether it belongs to W1, W2, or W3. All I have to do is I have to go through the 5, 10, 15, or 20 from k number of nearest neighbors, and I just try to take a majority voting of it. Simple. Are you clear, friends? The entire functionality of k-nearest neighbor is only this. Are you clear on this?
Sorry, Ajay here. Uh, let just try to clearly understand. So what you're saying is this new data point X. So what you do is you compare the properties of X to all the available other categories to see to which it suits closest, and you
Yes.
categorize it out of that. That's
Simple.
straightforward.
Based on the majority voting. Yeah, that's what. Perfect understanding. Right? Friends, are you clear on this? Any other questions? Appreciate your responses. Okay, so the reason the definition of k nearest neighbors or nearest neighbor classifiers are defined by their characteristic of classifying the unlabeled examples. When I say unlabeled examples, here in this example it is called xn. It is an unlabeled example by assigning them to the class of most similar examples. In my xn, I have chosen 5 nearest neighbors. Out of my 5 nearest neighbors, 4 belong to a class 1 and 1 belong to the square. So going by the simple principle of majority voting, I am just trying to live with 4 of class 2. Okay, friends, so this is what it means, and it is always makes sense for us to understand what are the different names for this. This is one of the standard interview question the moment you say or working on a k-nearest neighbors. So this is also called as instance based learning. Friends, what do you mean by instance? Immediate, quick. What do you mean by instance based learning? Okay, so as part of the traditional, okay, as part of the traditional machine learning process, right? So you're always coming with a mathematical model or mathematical relationship, right? But when it comes to k nearest neighbor, are we generating any mathematical equation here, friends? Do you see any mathematical equation that is getting modeled as part of the process? Is there any generalization in same of y equal to 2x or some kind of a mathematical formula here?
No,
No.
No, there is no explicit generalization here. Whenever a new problem statement comes in, I'm going to my training data and I'm going to compare this new data point with respect to all the data points present in the data set. Then I'm going to 5 nearest neighbors or 10 nearest neighbors or 20 nearest neighbors, and then I'm trying to make some predictions, isn't it? There is no generalization. There is no mathematical model that you are going to generate out of this particular approach, right? If there is a new data point that I need to classify, only then I'm visiting my training data. When I say visiting my training data, the entire data has to be available, isn't it? Right? There is no y equal to 2x that I'm going to generate here. So there's a need to compare my new data point with respect to all the data points. Why? Only then I will get to know who are my nearest neighbors, isn't it, friends? Because it is visually available here, so that you are able to figure it out who are your 5 nearest neighbors. But mathematically, you need to compare the new data point characteristics with respect to all the data points characteristics. Out of them, you need to take some k number of nearest neighbors. It could be 5, 10. We are going to find an optimum value for k, but for now we need to depend upon k nearest neighbors out of x number of total number of data points present in my training data, and out of the k, I am going to take a majority voting, right? So there's a, we say, instead of performing any explicit generalization, we are comparing new problem instances with the instances present in the data, which has to be stored in the memory. Agree? So there's it's called instance based learning. Only at the time of prediction, you're doing all the calculations. Agree, friends? Now are you clear why a k nearest neighbor is generally called as an instant based learning? Because only at the time of prediction, only at the time of classifying a new data point, only then the entire works happens. Agree? Are you clear about this?
yes, sir.
Right. And it is also called as a lazy learning. Why? You should be able to answer this now. In very similar lines. Why it is called as a lazy learning?
It is waiting till the last moment till we ask.
Simple, right? It's a lazy, right? Because there is no model that is getting generated or created. No learning of the model is required. All the work happens at the time when an end user asks for a prediction. Agree? Friends, able to understand this?
Yes.
Only at the time of prediction, the entire work starts happening. So then we say there is no learning of model is required here. All of the work happens at the time a prediction is requested. If there is no prediction, there is no learning. If there is a prediction, the entire work starts at that point of time. Okay? Are clear about this too? So we say no learning of the model is required here, right? And all the work of classifying or the predictions happens at the time whenever a request comes in. Whenever someone passes a new data and asks us to do this. Okay. And the next important thing is it is also called as non-parametric. What does it mean? When I say there are always two things that you need to understand. There's a parametric and non-parametric approach. What does it mean? There are no assumptions about the functional form of problem being solved. What does it mean? So as an example, there is a regression technique, right? The moment you wanted to use regression technique, first you need to validate few assumptions. Because if you have to use regression model, then there are list of 5 assumptions that you need to check. Only if they are satisfied, then you can use that particular machine learning algorithm and the statistical model. You got this point, friends? But when it comes to Knn, are there any assumptions? No assumptions at all, no strings attached. It means it is not going to make any assumptions about the functional form of the problem being solved. There are prerequisites. Prerequisites are different from assumptions. There are no assumptions at all. Okay, so the reason we call them as non-parametric. The moment you see any strings attached, any assumptions that needs to be validated, we call them as parametric approach. The moment you see non-parametric approach, what does it mean? There is no assumption at all about the functional form of the problem. Clear? So the reason the k nearest neighbor is called as instance-based learning, it is called as a lazy learning, and since there are no assumptions, so that it is called as a non-parametric approach too. Clear about this?
Yes.
Very good. Now coming to the applications. No, the moment I say I don't want to restrict saying that k nearest neighbor will only be used to the following problem statements, but you can always say as a these are the some of the best cases where k nearest neighbor was priorly applied and which makes more sense. Okay, but do not go always saying that k nearest neighbor would be the used only in the 5 to 6 applications that I have listed below. Okay, so generally, right, so historically k nearest neighbors have been used on the credit rankings, right, on the customer churn, right, and they have been used on the loan bankruptcy predictions, right, and sometimes interestingly, right, it has been used on the OCR, right. What does the OCR mean? Optical character recognition, right, and image recognition sometimes too. Okay, are you clear about them? Even though it's very simple, very fundamental in nature, so these are the best use cases that you can think about the moment when you see k-nearest neighbor. But again, all the machine learning solutions are data driven. Data drives the selection of model, not your predefined knowledge will try to help you on that. Okay, but if you want to see what kind of applications that traditionally being built using this algorithm, so these are some of the use cases which has been built priorly, just to give you an idea. But again, do not believe saying that only these 5 use cases only will be used for KNN. The moment you think about classification, you can always consider KNN as one of those fundamental basic model that you can always consider. Clear on this, friends? Any questions? And this is the proper structure that we're going to maintain. First, we'll provide a brief overview, then applications, then advantages, then disadvantages, then we are going to deep dive. Okay, now coming to the advantages. So looking at this particular introduction about Canaan, what are your thoughts? What do you think are the advantages? Friends, for the last 15 minutes, we have been learning about how does a k-nearest neighbor classifier will work and what are the different characteristics of them. Now looking at all of them, what are some of the keywords that you can relate with respect to KNN? Coming to the advantages. No one? Guys, don't worry about the
Relatively quick.
accuracy of your answer. Just share your thoughts.
It's relatively quick.
Simple, right?
Instance-based.
Since it is relatively quick, I would say that it's not relatively quick for the predictions, but it is relatively quick for the training phase, because any machine learning algorithm or solution will always happens in 2 phases, training phase and testing phase. So since, do you think there is any training that is happening in this particular problem statement or in this particular Canaan approach? No, isn't it? There is no training phase. Only when the testing comes in, only then the entire works happens. So the reason, instead of saying no training phase, we say one of the very fast training phases, because there is no model that is getting generated or created, right? And the moment we talk about this kind of an application, right, it is one of the simplest and effective thing. Okay.
That
And
is
the other,
Ajay here.
go ahead.
Question. What do you mean that there is no training phase? How so the categorization happens directly when you run the entire data model? Is it?
Ajay,
I mean,
so when you
I
started
always
the
thought.
description, Ajay, when you started the description, I'm always seeing the categorization.
Correct.
I'm not sure like what do you mean by categorization here. We are doing a supervised machine learning. Each input will have its corresponding output, right? When I say x equal to 1, y equal to 2, did I give the value 2 or did you give the value 2? It is already present as an evidence present in my data set, isn't it? You call them as
Okay.
categorization?
No.
Okay, then that is not categorization. That is called labeled information. Okay,
Correct.
Ajay, are you clear on this?
Okay.
So do
Yeah,
not
I'm
use
clear.
categorization. That's a very incorrect way of trying to articulate your understanding, right? That is not
Okay.
categorization. That is the data that is business has provided to you, right? The moment I say customer chain, what does it mean? You'll be provided some tens of variables, input variables, and they will say whether this particular customer has exited the organization or they're still within the organization, right? So that particular output variable is nothing but your labeled information. Those are not categories. Okay, if you wanted to say yes, it is a supervised classification technique, but you have not categorized them. Those is an evidence. So there's a way say it is supervised machine learning. Why? Every input has a corresponding output value defined, or we call this all the data has been labeled. Okay, Jay, are you clear about this?
I got it. I understood.
Okay, so the
Yeah,
reason
I
in
understood.
historically most of the times in machine learning it is all about generating some kind of a mathematical relationship or an algorithm to understand the association between your input and output. But whereas here we are not going to learn or we are not going to come up with any mathematical relationship here, right? From the training phase, all I have to do is I'm just trying to keep the entire data as my training. Whenever I want to do some predictions, I'm going to take the new instance, compare with respect to all the data points, find the some key number of nearest neighbors and try to take a majority voting. Simple. So the reason there is no training phase at all.
Okay.
Agree? Except from
Yeah.
partitioning the entire data set into two buckets.
Okay.
Okay, now
Thanks.
coming to the disadvantages. What do you mean by this? What are the disadvantages?
Accuracy could be low.
Okay, because it's a fundamental. So definitely I'm not very much interested or saying that it is one of the top-notch algorithm that you can always use. But before that, right, there are some fundamental flaws about this approach itself. Right?
So
No
we
clear, no
since
clear definition of the model. Like, we cannot define a model.
yeah
Okay, but
S-
articulate in a
since
different
we
way.
don't have the model, so every time a new no a new prediction will have to go through same
Excellent,
set of.
right? Whenever a new prediction has to come, it has to go through the same procedure. It means it is computationally very expensive, isn't it, friends?
Hmm.
The moment 101 record came in, I have to compare with 100 data points. 102 data record comes in, again it has to compare with respect to all the 100 data points, isn't it? So the reason it is very computationally expensive. Agree? Right?
Got it.
It has to compare a new data point that you wanted to predict or classify with respect to all the data points present in my training data set. Right? And since there is no model, do I need to maintain the entire data or not in my RAM?
Yes,
Yes.
entered it.
Right? In the earlier case, if I have a mathematical model, I can get rid of my training data. I can just dump it and I try to be working only on the mathematical model to productionize and try to make the predictions. But whereas here, there is no mathematical model or relationship that is getting documented. So that's what happens. I need to maintain how much the data might be. I have to maintain all the data in my RAM, isn't it? Right? So the reason I have a high memory requirement, isn't it? If you're working on 100 records, it's very simple, right? No one is going to curse you. The moment you're trying to work on some millions of records, think about the computation requirements and the memory requirement that I need to maintain, isn't it? So these are some of those basic fundamental flaws or disadvantages associated with k-nearest neighbors. Okay, and the other thing is it is sensitive towards your outliers. So what does it mean? Say as an example, I'm trying to compare 5 nearest neighbors, and as an example, right, maybe 3 of them might be an exceptional behavior. Ideally, the 4 nearest neighbors that you're trying to see here might be they actually should belong to W2, but because of the sensitive or overlapping of information, they have been classified or they have been given as W1. Right? What happens? The entire predictions will go away, isn't it? Right? So the reason this is one of those algorithms which is very, very sensitive to outliers. It means it makes sense for you to clear the hurdle of outliers presence in your data set. So it means as part of your data pre-processing work, this is one of those things that you need to always remember and try to remove any outlier behavior present in your data set. You see this, friends? It means if you are in a hurry to fit in an algorithm without paying attention to the data anomalies, what happens? Your predictions will go very wrong direction, isn't it? So the reason, as I said, EDA followed by data pre-processing followed by feature engineering or feature selection is the right way before you start applying any model. Okay. because this particular algorithm is very sensitive towards our outliers. The moment you have an outliers, then definitely you're not going to get a good thing or good predictions or good accuracy of the model. Clear?
Yes, sir.
Friends, are clear? Able to follow?
Yes.
Yeah, yes, sir.
Friends, from today, right, I'm definitely look for some good acknowledgements, right? If I'm not going to get it, right, then it will really not help me at all. Okay, please do make a habit of acknowledging either through voice or through chat. Thank you. Now, when can you use KNN, or what kind of situations that you can always refer to a KNN? So the moment you try to see all the input variables which are in continuous values, right? Traditionally, the moment you are trying to work in a real world, it is very hard for you to get all the variables in a direct numerical format. But whenever you try to see the relationship between your input and output variables are very numerical in nature, right? You can always think about using the KNN. This is the first case. And whenever you see the items of a similar class type tend to be fairly homogeneous. What do you mean by homogeneous? You got a better understanding, right? What is homogeneous and heterogeneous? We have seen this before.
Similar stuff.
Okay. The homogeneous means it is always about similar properties, similar characteristics among itself, right? The moment you are trying to work on a data set where all the records of a particular class, here we have taken three classes, so W1, W2, W3, circles, triangles, and squares. But whenever you see all the records present in a particular class are fairly homogeneous, there is no overlapping, there is no stepping into other class values, right? There are no outliers, there are no anomaly behaviors. The data is pretty clean and very straightforward, and in all those cases you can prefer KNN, right? But again, right, from understanding perspective it may be very simple, but when you try to relate it to your real world problem statement, it might be complicated, because I'm using a simple two-dimensional x1 x2. I'm trying to plot the data point values, and I'm going to talk about comparing a new data point with respect to existing and trying to take it. But when you're working on some thousands and millions of records, when you're having 20 dimensions, 40 dimensions. When I say dimensions, nothing but the number of columns, right? The moment you try to increase the dimensions and the complexity, right, it would not be that easy, right? Definitely the real world scenario might be complicated. Agree? So this is what you need to always see, like when can you use a KNN. So the moment you think the relationship between input and output variables are pretty much numerical in nature, when I say numerical in nature, the input variables to be of pretty numerical, and it can be easily configured, or it can be easily figured out using a distance matrix. And as I said, items of a similar class type, right, it has to be fairly homogeneous, right? It means it needs to clearly share a similarity among itself. Okay, so these are some of the cases where you can use your k-nearest neighbors. But again said, any machine learning algorithm choice is completely dependent on the data. Okay, no one can say that the moment I look at a problem statement, customer churn, no one can say, hey, let's use KNN. No, it can never happen that straightforwardly. If that is the case, there would be only one product or solution that would be available in the market, which is going to solve all the possible customer churns, right? As the domain differs, the data differs. As the data differs, the choice of the algorithm will differ. But just a tentatively points which you need to remember, which will help you to shortlist, right? Instead of trying to loop all 10 algorithms, maybe you'll in a matured position maybe to refer to 2 to 3 algorithms based upon the characteristics exhibited by your data. Okay, clear on this?